we're going to do what? We're going to revise some trigonometry. Let's start with the right angle triangle, okay? Okay, so for right angle triangles, we need to remember three things. The first thing is the rule of Pythagoras, okay? The rule for Pythagoras, we're saying what? If we have a right angle triangle, A, B, and C. If we have A and B, two sides, we call the hypotenuse C. That's the hypotenuse, that's the longest side in the right angle triangle. So A squared plus B squared equals C squared, okay? So if I want to get the hypotenuse, I will do square root of A squared plus B squared. And if I want to get the short side, the one that's next to the 90 degrees, we will do minus instead of plus, okay? So we're gonna do, if A or B, that's root, and make sure that you have the bigger first, C squared minus B squared. So that's the first thing, the Pythagoras rule. What else? We need also to remember the trigonometric ratios, the sine, the cosine, and the tan, okay? So for the sine, or for any right angle triangle, okay, 1 second, I'm sorry. Okay, here it goes again. We have the following, okay? That has a problem, and I don't know why today. Okay. Can you hear me? Okay. So we were doing the right angle triangles and we missed the trigonometric ratios, okay? So if we have another right angle triangle, and we have an angle inside which is x, for example, okay? That's the right angle and that's the angle x. Now, if you want to get the angle x or to get any of the sides, we have three basic rules. First, we have to name the sides. The side that's opposite to the 90 degrees is called what? It's called the hypotenuse. We agreed that that's the longest side in the triangle. And the angle next, the side next to the angle is called adjacent. And the side opposite to the angle is called opposite because it's opposite. So any angle has three main ratios. Sine x, that's opposite, over hypotenuse. So if we take the first three letters, S, O, and H, that's so. You can remember it with a triangle. Sine equal opposite over hypotenuse. If we took the other side, the other ratio, cosine x is adjacent over the hypotenuse, right? And if you took the tan, that's opposite over the adjacent, okay? So if we took the three first letters for every ratio, that's cosine, A, H, the T, O, A. So some of us remind us as SOH CAH TOA. SOH CAH TOA. So sine equal opposite over hypotenuse, CAH, cosine equal adjacent over hypotenuse, and tan, which is opposite over adjacent, TOA. Okay? You have a problem with that? Okay. So let's practice some questions. If we have a right angle triangle like question 2. That's question 2 from June 2011, paper 4H. We have a right angle triangle and we want to get the length of LM. Okay? How do we get the length of LM? Okay, if I want to get the length of LM, first I will name it X. Okay, that's the unknown side that I want to get it. Now, I have to name the three sides of the triangle. who's the hypotenuse, who's the adjacent, and who's the opposite. So 9.3, that's the hypotenuse. Why? Because that's the longest side in the triangle, so it's called the hypotenuse. Okay? What about the x? The x, is it next to the 42 or opposite to the 42? It's opposite to the 42. So we name it the opposite. We name it what? The opposite. So sine the angle, which is 42 degrees, equals the opposite, which is x, over the hypotenuse, which is 9.3. Now I want to get the value of x. That's my unknown. So I'm removing the 9.3 to the other side with times. So x equals 9.3 times sine 42. And what is 9.3 times sine 42? Let me have my calculator. So 9.3 times sine 42 equals to 6.22 as rounded to 3 significant figures. So I will write my answer 6.22. Okay, let's have another example. Here in this triangle, we want to get the value of the angle x. So first, I will name the sides. 5.8 is the longest side, it's opposite to the 90, so that's the hypotenuse. Okay, 3.4 is the side opposite to the x, so that's the opposite. Now, sine x equal the opposite over the hypotenuse, so it's equal to 3.4 over 5.8. If I want to get the angle x, so that's sine inverse of 3.4 over 5.8. On the calculator, we do it shift sine, okay? So x equal shift sine 3.4 over 5.8. So that's 35.888. Now we need it to one decimal place, so that 35.9 degrees. Easy? Okay. Welcome back to the meeting, Yusuf.
ازيك يا مستر؟ I'm so sorry بجد.
Never mind. You still have the same problem, right? The same internet problem.
لا لا
Now it's better?
اه
طيب الحمد لله. Okay.
بس الانترنت اللي في الراوتر خلص فشغلت اللي في الباقة بتاعتي.
Never mind. Okay. طيب. Yusuf, can you help me do question 4? We have
Yes.
2 sides, and we want to get the third side. Okay? How do we do it?
Yes.
Do we use the trigonometric ratios or we use the Pythagoras theorem?
Pythagoras Theorem.
Well done. So what do we do? X equals to what?
Root.
Root, square root. Thank you. Yes.
5.6 squared
5.6 squared
plus
well done, 3.7 squared. So we're going to use our calculator. That's 5.6 squared plus 3.7 squared, which is 6.71, rounded to 3 significant figures. Okay? Okay. May you close the mic, please?
Yes, sure.
Switch it off. Okay, thank you. Okay. Here in question 6. In question 6, we have triangle LMN. Calculate the length of MN. So MN, that's 3x. That's the unknown that I want to get, right? So first, I will name the sides. That's the 72. That's the hypotenuse that I don't want to get, okay? And that's the opposite to the angle. And 34 is the adjacent to the angle. So which trigonometric ratio has opposite and adjacent? The one that has opposite and adjacent is the tan. So tan 72 equal the opposite, which is x, over the adjacent, which is 34. So if I want to get the value of x, I will do 34 tan 72, which is 34 tan 72 equals 104.64. Now I want only 3 significant figures. Okay, so we write only 105. Easy. Okay. Yalla. Yusuf, it's your turn again. Let's do question 8 together.
Okay.
So step number 1, we do what? We name the sides, right?
Yeah.
So he's asking you to calculate the length of BC. So I will name the BC X. Okay, what do you call 7.9?
Hypotenuse.
Hypotenuse. Thank you. So that's the hypotenuse. And what do you call the X? It's next to the angle.
Adjacent.
Adjacent. Thank you. Now, which trigonometric ratio has the hypotenuse and the adjacent?
Cosine.
The cosine. Thank you. So cosine 38 equals the adjacent over the hypotenuse, which is x over 7.9. Do you agree?
Yes.
Now I want to get the value of the 7 point of the x. So I am gonna move the 7.9 to the other side with what? Times. So the x is 7.9 cosine 38, right?
Yes.
So now we're gonna calculate it.
6.225.
6.225 cosine 38, 6.25, 62.25. No, 6.225. I'm sorry. 225. Now we need it to three significant figures, Yusuf. What do we do?
We're on the 5 is gonna be 6.23.
What?
We're gonna round the 5.
Mm-hmm.
So it's gonna be 6.23.
Thank you. 6.23 centimeters. Well done. Okay? Okay. Give me a second. We need a question. I'm going to tell you right now. Yes. Question 9. So in question 9, do we use the trigonometric ratios or we use the Pythagoras? You have two sides and you want the third one. Pythagoras. Okay, what you're going to do? One more time. You have the 6.8 is the opposite. And the x is the hypotenuse, as you said, right? So which rule are we going to use? Sine. Sine theta, which is the angle, equals the opposite over the hypotenuse, right?
Yes.
So the theta, the angle is 52 degrees. The opposite is 6.8 and the hypotenuse is x. We need to get the value of the x here, Yusuf. So we're going to move the x to the other side with times and we're bringing the sine 52 down with division. So that's 6.8 over sine 52, which is
8.629.
8.629.
29.
So three significant figures, that's
6.2.
8.63, right?
Yes.
So that's 8.63. Easy?
Easy.
Okay. Thank you. It was making so much distortion. Okay. So now we have the bigger triangle ABC, that's a right angle triangle, and we have also the smaller triangle DBC. So now we need to find the length of BD, this question. But we only know one information, the triangle, which is the angle, that's 51 degrees. In order to solve any triangle, we have to know at least two pieces of information. So I'm gonna solve the right angle triangle, the large one, the ABC first, to get the value of BC. So now I'm gonna make BC my x, okay? And let's solve this triangle. If I'm gonna get confused, I'm gonna take the triangle outside. That's A, B, and C. Okay? A, B, and C, which is right angle triangle at B. So that's 47, and the angle is 32 degrees. So now the 47 is my hypotenuse, and I want to get the BC. So x is my opposite, BC is my opposite. So sine 32 equal the opposite, which is x, over the hypotenuse, which is 47. Gonna move the 47 with times. So x is gonna be 47 sine 32, which is what? Let me have my calculator. So 47 sine 32. That's 24.9. Okay. Now I'm gonna use this information, this piece of information, the x, to solve triangle BDC. Now in triangle BDC, I have 51, that's my angle. The x is gonna be my opposite. And the BD, the one that I don't know, is gonna be my adjacent, right? It's next to the angle, so anything next to the angle is called the adjacent. So that's my adjacent. So which one has opposite and adjacent? That's the tan. So tan 51, which is my angle. I always put the angle inside the trigonometric ratios as we agreed before. That's the opposite, which is 24.9, over the adjacent, which is BD. Okay, now I need to get the value of BD. What do? I will get the BD to the other side with times, and I'm bringing the tan below. So BD equals 24.9 over tan 51. Over tan what? 51. So 24.9 divided tan 51. That's gonna be 20.163. But he only needs 3 significant figures. So we're gonna say 20.2 meters. Okay? So the trigonometric ratios, the Pythagoras, are for the right angle triangles. We can do it on a multi-step problem or a single step problem. Single step problem is when I have only one triangle and I have only one missing value. Multi-step questions is when I have like more than one triangle. I'm gonna do more than one step to get what the unknown that I have. Let's have another example of this. Okay, here we need to get the height AB of the flagpole. Okay, connect to 3 significant figures. So what can we see? We can see 2 right angle triangles. Okay, one smaller, which is the BCD, and one bigger, which is A, B, C, and D. Okay, and we need to get the length of AB. We have only the AD and we have the BD. But we don't have much information. We have only one information, which is the 16.5. So what do we do? Let's name the BCD as X. Okay? So, and the BC as Y. Okay? So, let's take the smaller triangle, BCD, or CBD, because we the right angle, so we have to put it in the middle. So tan 59 equals the x over y, right? So the y equals x over tan 59. Do you agree? Let's have the bigger triangle, okay, which is ABC. We're gonna take the same ratios result. So in triangle ABC, the angle is 69. So tan 69 equal the opposite. Now the opposite, it's not only the x, AB the opposite. So that's 16.5 over x plus x, I'm sorry. 16.5 plus x, that's the AB, over y. So the y here equal 16.5 plus x over tan 59. But y was also x over tan 59. So we can formulate an equation here that this is y and this is y. So from 1 and 2, we can say that x over tan 59 equals 16.5 plus x over tan 69. So we do cross multiplication here. So x tan 69 equals 16.5 plus x times tan 59. So first, what's tan 69? 2.6. So 2.6x equals what's 16.5 times tan 59? That's 10.8. So 10.8 plus tan 59 times x, which is 1.67. So 1.67x. I'm going to move this to the other side. So we have 2.6x minus 1.67x equals 10.8. That's 0.93x equals 10.8. Now let's get the value of x. That's 10.8 over 0.93, which is 11.61. So to three significant figures, that's 11.6 meter. Okay? Easy. So that was trigonometry for right angle triangles in 2D. Thank you.